So funny story, I already recorded this video, but I forgot to press record. So now I'm going to have to go through all of the information all over again, and I feel great about it. Okay, so here we are going to graph trig functions. Now, we have graphed other types of functions before, but this is going to be a slight bit different. Usually there is a certain pattern, then it just goes off to infinity. This is kind of the same, but as we know, these functions are periodic, so it's just going to wave on to infinity that way. We need to know a couple of bounds of the function, and then we'll actually be able to fit it into the graph. So what are some of those things that we are going to need to know? We are going to need to know the period, basically where this cycle begins and ends. Once we get one cycle down, it is pretty easy just to kind of continue the cycle after that. So first of all, we need the period. So let's find the period. We got period equals 2 pi this time over the absolute value of b. Why 2 pi? Because if we look at our graph, the x-axis or the theta axis is measured in radians. So this time we're going to use the 2 pi, the radian measure of 360 instead of 360. Now this one's actually pretty easy because as we can see, the number in front of theta or our b value is 1. So this is just going to equal 2 pi over 1, which is just going to be equal to 2 pi. Now, what does this tell us about our graph? This tells us that a whole cycle is going to last exactly 2 pi units. That means that our cycle is going to end at 2 pi. Now, it's going to begin at this point right here, this 0 mark. The whole graph is going to take place within those bounds. Now we need to know where our midline is, the top, and the bottom of the graph. First of all, our midline. We haven't really gone over moving our midline yet, so until we do, always just put your midline at 0. So now I know where my midline is. I now need to know where is the top and where is the bottom of this graph. The way that I figure out my top and the bottom is with my amplitude. So my amplitude, if we remember, is just going to be the absolute value of A. Now my A value is 2, so therefore my amplitude is going to equal 2. The amplitude is how far off of the midline it goes at the top and the bottom. So I'm going to draw 2 more dotted lines to show what are the bounds of this graph going up and down. Notice I drew 2 more dotted lines. The amplitude being 2, it goes 2 units up from the midline and 2 units down from the midline. So now I have all of the bounds that I need. Now we're going to go back to our period. Notice our period starts at 0 and it ends at 2 pi. I want to divide this up into 4 equal parts, or divide it into half and then both sides into half. So for instance, my halfway mark is going to be right here at pi, and my halfway mark on the right side is going to be right here at 3 pi over 2, and then my halfway mark on the left side is going to be at pi over 2. Now everything's marked so it's a little bit easier to see, but maybe in the future we might need to mark those ourselves. I'm going to write them out just so it's a little bit easier to see. Alright, so we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. We have everything that we need to graph this now. Now, being that we're working with a sine function, it does follow a certain pattern that we could kind of exploit here. If we're working with sine functions and it hasn't shifted to the right and left, that means it's going to start at 0. But just to make sure, what you can do is just throw in 0 into this equation. Now, our equation was y equals 2 sine theta. We're just going to say 2 sine of 0. Now, one thing that we have to make sure is that we are in radians, because now we're working with radians. Here we can see that, yes, we are in radians, which is the superior form of measuring an angle. So thank you, Desmos, for that being your standard. Now, if you notice, 2 sine of 0 equals 0. What does that mean? When we plug in 0, we get out 0. So on our graph, we're going to have a point at 0, 0, right over there. Now, a general sine function looks like this. It starts at some point, and then it goes up to the next point, and then down back to the midline, and then down to its lowest point, and then back up to the midline. So that's the pattern that we're going to follow. If you notice, on our graph, we have 5 different spots here that we can do all of these points. It's going to start at 0, 0, and then it's going to go up to the maximum height, and then it's going to go back down to the midline, and then down to the lowest point, and then back to the midline. What we're going to do now is that we're going to connect these dots with curved lines. Once we do that, you'll see that this looks like a sine function. And we have successfully graphed what our sine function looks like. Now, this is pretty much all that we were going to want you to do. This does go on and on and on forever. For instance, if you go in the reverse direction, it seems that every 2 of these units, another one of these steps take place. So it's going to go all the way down to the bottom, and then it's going to go up to the midline, and then it's going to go to the top, and then it's going to go back to the midline. And we get this rest of the sine function. It's going to go like that forever to the right, and then forever to the left. So just follow the pattern of dots. We are going to try this out with our cosine function, and we need all of the exact same things that we needed for the previous one to be able to tell exactly where to graph this. So we will need our midline, we will need our amplitude, and we will need our period. So let's start off with our midline. Again, we haven't gone up or down yet, and you don't know how to do that yet. So our midline is just going to be at 0. Now I want to see my amplitude, so how far up and down this function goes. Our amplitude is going to equal the absolute value of A. Our A in this case is 1, so our amplitude is going to equal 1. So the maximum point is going to come 1 off of this midline, and the minimum point is going to come 1 down off of this midline. Now I have literally put this 1 unit above and 1 unit below. Another thing that we could do is just kind of fudge the results a little bit, like put it 4 units above and 4 units below, and then just label it as 1. That would totally work as well. But just for the sake of graphing it, properly, this is what I'm going to do. Now we need to find out what our period is. Our period is going to equal 2 pi over our absolute value of B. So our period will equal 2 pi over 4, and that's easy enough to simplify. So our period is going to equal pi over 2. That's 2 over 4. Simplified to 1/2. That means from start to finish, our period is going to be pi over 2. So our start is going to be here, and our finish is going to be here. That seems rather short, and you know what? It is rather short. What are we going to do to graph this? I want to zoom in here. So zooming into this part of the graph, we still have to split it up half and then half again. So we're going to split this into half, and then we're going to split the right side into half, and then the left side into half. And we're going to then graph our trig function. Now, I know that the lines on the graph, the crosshairs don't actually match up with what we have, but we're trying to graph this accurately, so we have to make it look like this. Now we know that this is going to be 0 and this is going to be pi over 2 because it's labeled, but what are the other points going to be? Well, the middle point is just going to be pi over 2 divided by 2 again, or times 1/2, which would make it pi over 4. And then to get the half of that half of a point, you're going to multiply it by half again. So that's going to be pi over 8. And then how do you get this point over here? Well, we know that this is pi over 8, and you take 1, 2, 3 to get there. So that's going to be 3 pi over 8. That's how you label your points. Just half it again, and then multiply it times 3 to get to that other one over there. Please re-watch that a couple times until you really understand how to label those points, because it could be kind of important later on a test. Now, what we're going to do is that we're going to use the standard way of graphing a cosine function. Now, I showed that for the sine function above, but for the cosine function, this is what happens. You're going to start at the maximum, and then you're going to curve down to the midline, and then you're going to curve down to the minimum, come back up to the midline, and then go back to the maximum. So let's do those points. First, I start at the maximum. Then I'm going to go to the midline, and then I'm going to go down to the minimum, and then back to the midline, and then to the maximum. Now, it looks like a V right now, but we remember we have to connect these with curved lines, and it's going to look like a wavy thingy. So let's connect these with curved lines. Curve, 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 and curve. And look at that. We have our cosine function. So I just want to show it real quick. If we continue this out, it seems like each period is going to be pi over 2. So this will be the periods. And if we continue out this graph, it's going to repeat that every single time. So it's going to look something like this, and then like that, and then like that. Now, my artistic skills is not all that great, but as you can see, it just kind of continues down the graph. But all you really need is just that little section that we graphed initially, and you should be fine for a test. Now it's time that we do some guided practice. So give these a shot and see if you can do these by yourself. Good job on trying these out by yourself. Now let's go at this together, because these can be a little bit tedious. First things first, we're going to draw out our midline, and then we're going to put our maximums and minimums based on our amplitude being our absolute value of A. So in this case, our amplitude is going to equal 3. So let's draw out our top and bottom like so. And now we want our beginning and our end of our graph, or our period, how long each cycle takes place. Our period is going to equal 2 pi over our absolute value of B. So in this case, that will equal 2 pi over 1, or we could just say 2 pi. So our beginning is going to be at 0, and our end is going to be at 2 pi. Now what we're going to do is divide this in half, and then both sides of those into half. Half, half, and half. Now we have everything that we need to graph this. Now we have to ask ourselves, is this sine or cosine? In this case, it is cosine. So we are going to start at our maximum, and then go down to our midline, down to our minimum, back up to our midline, and then to our maximum again. So maximum, midline, minimum, midline, maximum. So let's connect these with curved lines, and see what our final graph looks like. And look at that, we are all done graphing. Now again, as you know, and I've reiterated many times, this is going to go on forever in both directions, and you can keep on adding sections of this graph if you wanted to. Let's look at 2b. It looks like it's a little bit more involved, but it's actually not that bad. First thing is first, and we are going to put in our midline. Boom, midline. Now we're going to put our maximum and minimum. This is based on our amplitude. So our amplitude in this case, absolute value of A, our amplitude is going to equal 1/2. Now, I don't want to make a line half a unit up and half a unit down. So I'm just going to pick an arbitrary line above this and call it 1/2. Now, this is very obviously not 1/2. But if I say this is 1/2 and down here is -1/2, now it is because I say so. So you can say so too on your graph. Now we need our period. Period 2 pi over absolute value of b. That will be 2 pi over 2. The 2's cancel out, so this will just be pi. So we're going to start at 0 and we're going to end at pi. Now we need to divide into half and divide into half again. This will be divided into half, which is very conveniently at pi over 2. But this one is not quite going to be on a line, so we're going to have to label that ourselves. And this one is not quite on a line either. So what is pi over 2 times 1/2? That's going to be pi over 4. And how many pi's over 4 do we need to take to get to this line? Well, let's find out. 1, 2, 3. It's always going to be 3. So that's going to be 3 pi over 4. Now, as we know, this is going to be pi over 2 because it's already labeled, and this is going to be pi over here, and this is going to be 0. Now let's draw our graph. We know this is sine. Sine starts at the midline, goes up to the maximum, back to the midline, down to the minimum, and then it finishes off at the midline. So let's draw our points. Start at the midline, go to the maximum, back down to the midline, all the way down to the minimum, and then back at the midline. Let's connect all of these dots with curved lines and we will be done. Curve, curve-ish, curve and curve. Now we have our graph. And again, it keeps on going to the right, and you could add more points if you wanted to, but this is fine for a test. Very good job. I know this was a little tedious, but stick with this. Look back at this lesson because there's a lot of little things that you probably missed that would be good to go back over. But see you in the next video. Okay, good. I actually recorded it.